Welcome to this Razorpay Python Developer interview preparation session. In this video, you will get 5 real interview questions with structured answer strategies. Follow the interviewer prompts and structure your response for strong selection outcomes.
Can you explain how to implement HMAC signature verification for incoming Razorpay webhook payloads using Python? I'm interested in your approach and key considerations.
To implement HMAC signature verification for Razorpay webhooks in Python, first I retrieve the payload and the signature sent in the webhooks header. I compute the HMAC SHA-256 hash of the payload using the webhook secret key. Then I securely compare this computed digest with the signature provided to ensure authenticity and prevent timing attacks. The trade-off is the extra computational overhead, but it's essential for security. I also handle edge cases like missing headers or invalid signatures by rejecting those requests to avoid processing fraudulent events. This approach ensures webhook payload integrity and prevents unauthorized notifications.
Can you explain how you design a Python SDK that wraps a payment REST API, incorporating retry logic and error normalization?
To design the SDK, it create methods that wrap REST endpoints and embed retry logic using exponential backoff to handle transient failures. I would normalize all API errors into consistent Pythonic exceptions so developers get a unified experience. The trade-off here is balancing retry aggressiveness and performance, avoiding user frustration with delays. For edge cases, ID specifically address rate limits and network glitches by raising appropriate exceptions after retries fail. This approach ensures the SDK is reliable, predictable, and easy for developers to use with payment APIs GAS.
Can you explain how you would implement idempotency keys in a Python payment processing endpoint to improve reliability?
In payment processing, idempotency keys prevent duplicate transactions by associating a unique key with each request. I implement this by storing the key with the transaction data and response in a database. On receiving a request with an existing key, I return the previously stored response instead of reprocessing. This ensures reliability but requires robust storage and expiry management to handle stale keys. I also handle edge cases like network retries and partial failures by ensuring atomic writes and valid rollback mechanisms. This approach balances consistency and performance effectively.
Can you explain how you would use Python enums and data classes to effectively model payment states within a checkout service?
To model payment states in a checkout service, I would use Python enums to clearly define all possible payment states like pending, completed, or failed, which brings clarity and type safety. Then, I would use data classes to represent a payment object that includes its current state along with relevant details such as amount and transaction ID. This approach keeps the code clean and easy to maintain. A potential trade-off is the immutability constraints of data classes, but this can be managed with mutable fields or methods to update state. I would also handle edge cases by including a default or error state to manage unexpected situations. Overall, this method creates a scalable and organized way to manage payment states.
Can you explain how you would safely store and handle rotation of API keys and secrets in a Python-based payment service application?
In payment services, API keys and secrets must be stored securely outside the codebase, typically in environment variables or secrets management systems like Vault or AWS Secrets Manager. I implement automatic key rotation by automating updates and service restarts with zero or minimal downtime. A trade-off is balancing security with availability. Rapid rotation can cause brief service interruptions if not handled well. To mitigate this, I incorporate caching and fallback to previous keys during transitions. This ensures continuous operation while maintaining strong security practices.
This completes your Razorpay Python Developer interview preparation set. Practice these answers aloud, refine clarity, and repeat daily for stronger interview performance.